Okay, goal 4.2 deals with factoring specifically two-term polynomials, okay? And all of the ones that we're going to do have special names to them. So we did some two-term polynomials just now, but they were just common factors, and that's all they can do. So the first thing we're going to talk about is a difference of squares. A square is a product that has two of the exact same factors. Examples include, you know many of these already. 1 is a square. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144 are probably the first 12 that you already know. It is good to know. I'm not going to ask you to memorize. Maybe you have to do this in geometry. But the next set of perfect squares up to 20. Okay? 169, 196, 225, 256. What am I at? 15, 16, 17, 289, 324, 361, 400. The first 20 perfect squares, commonly used in geometry, right angle, triangle geometry, right triangle geometry, okay? Two factors that are exactly the same. 18 times 18, 324, okay? On your calculator, if you're not sure if something is a square, you can find out. So let's look at our calculator. On the very left side of the calculator, 1, 2, 3, 4, 5 down. 5 buttons down is the x to the second button when you go to square something. But above it in blue is a radical or square root symbol. So if I want to take a square root, so like let's say I put in 361, so I press the blue button first, and then the x squared button, and you will see the radical symbol pop up on your calculator. I can put in 361, enter, and I get 19. So that tells me that 361 is a square. Some popular squares that I did not list, 625 is a popular square, 25 times 25. So if you're not sure, you can use your calculator square root button and find out. If it comes out an integer, it's a square. If it comes out a decimal, it's not a square. Okay? So you might want to use that. I don't know. But we have several. Obviously, an infinite number of squares that are numbers. But we also have variables. By its name, x squared is a square. X times x. X to the fourth is a square. X squared times x squared. X to the sixth is a square. X to the third times x to the third. X to the eighth, etc., etc., etc. The pattern is that any variable with an even power is a square. Any variable with an even power. It looks like bannable. There we go. Any variable with an even power is a square. There are a couple trick questions, and you better believe I'm going to try to get you on them. Make sure you really know. We're talking about squares, which we'll get to in a second. Okay? First of all, it's important to recognize that you have a difference of squares, because we're doing like part 1 today of goal 2. Part 2 involves cubes. And so you're going to have to recognize when you look at a question, am I working with squares or am I working with cubes? So right now we're just working with squares, but that's important to identify. Okay? What I have in red here, I don't want to call it a formula because that's not what it is, but when I break up a difference of squares, when I break it into my parentheses, which is the factoring process, this is what it factors into. The first term, which is a squared term, goes in the first spot and the first spot of the parentheses. The second term, the last term, which is a square, breaks up to the last spot and the last spot. And then you'll notice that my signs are opposites. It does not matter if the plus or the minus comes first, just so you have one of each. Two reasons this happens. First of all, because the last times the last has to give you the last. So opposite signs, positive times negative, will give me this negative. And the other reason opposite signs are important, because if we FOIL this completely out, you'll notice that we're going to get a negative AB and a positive AB, which drops out the middle term. So when you factor a difference of squares, we get this, which we call and refer to as, does anybody remember from your notes? Remember I said if you had these when we were multiplying, you wouldn't necessarily have had to multiply because the outers and inners were going to cancel. Do you begin with the C? Yes. Conjugates. So when you factor a difference of squares, you factor it into conjugates. Okay? So we'll start off simple and then we'll build. X squared minus 36 is a difference of squares. And when I break this up, x squared breaks to x times x. 36 to 6 times 6. One gets a plus, one gets a minus. And I'm done. Looks like 61. Second example. I have squares. 16 minus x squared. So 16 is 4 times 4. X squared is x times x. One gets a plus and one gets a minus. And it does not matter which one gets which sign. X squared minus 9y squared is a difference of squares. X squared is x times x. 9y squared, 3y times 3y. One gets a plus, one gets a minus. I'm going to get harder, or at least a little more challenging, not hard. 36x squared minus 1. It is a difference of squares. 6x times 6x. 1 times 1. One gets a plus, one gets a minus. (49x to the 16th minus 64y to the 4th). All squares. Here's my little trick one. 49x to the 16th is 7x to the 8th times 7x to the 8th. And then 64y to the 4th, 8y squared times 8y squared. One is a plus, one is a minus. That x to the 16th, that's where I was trying to trick you. Because when we divide a power up, we just split it evenly. But the trick is that it's 16, so sometimes people put x to the 4th times x to the 4th. Okay? So a power as a square just gets divided by 2. Okay? Okay, questions so far? Something you want to ask so far? Probably one of the more challenging things about factoring is, especially when we get to the end of everything, at the end of Super Goal 4, is knowing if you're finished. Because just because you factor doesn't mean you can't go further. Okay? So there's kind of like 3 rules of factoring in general. You're always going to look for a common factor. Take it out if there is one. Then you're going to factor it if you can. And then you're going to say, can I factor it further? Okay? So this is an example of that, factoring it further. X to the 8th minus 81. So x to the 8th breaks to x to the 4th times x to the 4th. 81 breaks to 9 times 9. One gets a plus, one gets a minus. But I'm not finished because I still have another difference of squares. This created another difference of squares. X to the 4th minus 9 is a difference of squares. And this is why recognizing what a difference of squares looks like is important. X to the fourth plus 9 does not factor again because it's a plus. But x to the fourth minus 9 does factor. It will break to x squared times x squared. 9 will break to 3 times 3. 1 will get a plus and 1 will get a minus. And then I look again. So be in the habit of looking and seeing and asking yourself, am I finished? X to the second minus 3 will not factor again. We do have a square. We do have a minus, but 3 is not a square. So that's as far as I'm going to be able to go on that question. Okay?
So you can only go farther when it's a minus.
When it's a minus, yes. Well, let me specify. Let me answer that question a little bit differently. I can only go further if it's a minus squares, because we're going to do minus n plus cubes, and they both go further. Okay? So for squares, it has to be a minus, yes. Okay. Now, if you look at this next example, I only have 2 parts that, like, this whole term is not a square. Part of it is, but the y is not. And part of this is a square. The 16 is, but the y is not. So we always go to rule number 1. So what I will tell you is now, right now, is the time to get in the habit of 3 things. Is there something common? And if there is, take it out. Then factor it. Then, can I factor more? So 3 steps. You're going to start thinking that for every question that we're going to do. Is there a common factor? Yes, I can take out a y. And then I have x to the fourth minus 16. Do I get a difference of squares there? Yes, I do. So I'm going to have x squared times x squared gives me my x to the fourth. 16 will break to 4 times 4. 1 gets a plus, 1 gets a minus. And then can I factor further? Why, yes, I can. I get a difference of squares right here. This is a square, power is even. 4 is 2 times 2. So my y will come down. X squared plus 4 will come down. And then this one will break up again. X times x, 2 times 2, plus minus.